Okay, this is recording number 1 for June 29th, and it's only the women here tonight, and I just gave all the answers to the test next week, so sorry guys, you won't be included, but better luck next time. So let's start it off with example number 1. We actually did example number 1 a few different times. So this is a situation where you give a drug to people, and I think from last week we talked about the idea, okay, I have 3 people I give the drug to, 3 people I don't, and then I measure their, what did we say it was last week? Was it memory? I think it was a memory situation. So can we as a group identify the independent and dependent variables there? Miss Emily, could I ask you on that question? What kind of independent dependent variables? What's the dependent variable in this case?
The memory score.
Yeah, the memory scores. It's the variable you collect. Alexis, is that good for you?
Yes.
So it's the memory score. Beverly, is that good for you as well?
Yes.
And how about, let me ask Beverly, what is the independent variable?
Whether they receive the drug or not.
Yeah, you would actually call it condition, and you would have 2 levels, no drug and drug. Is it a within subject or a independent samples type of design? Alexis?
Independent sample.
Yeah, it's independent sample. We could actually do 2 different statistics on this, couldn't we? We could do an independent sample t-test if we wanted to. We could also, as we learned last week, do a 1-factor ANOVA. So we're going to go ahead and do that with the computers here. So let's actually have the ladies in the room, and Beverly as well, set this thing up in SPSS. So Emily, do you remember how you set this thing up?
You go to analyze.
Not quite. You got to put the numbers in first, don't you?
Right.
So you might want to start with,
1, 2, and 3.
yep, you can put in 1, 2, and 3 in the same column as 5, 6, and 7. So in one column, put 1, 2, and 3, and 5, 6, and 7.
See.
And make sure Emily did it right.
I missed.
That's okay. 1, 2, and 3. Nope.
What is it?
You got to hit
What's
the
it
enter
not
key, honey.
doing? I was hitting the enter key.
Oh, so you do them all the way down.
Yes. If it's an
Okay.
independent sample, you put them all in one. And then in the other column, what do you put in the other column?
You put 1 and 2.
Yeah, 1, 1, 1, and 2, 2, 2. So just going down. Are you okay with that, Beverly?
Yes, I'm still working on it.
Okay, so the other thing we have to do, notice it created this variable 00001 and 00002. So now we go into variable view. And if we had done it before, we can change the names now. So under variable 1, that's what, the independent or dependent variable? Was that the score? Go back to the data view, Emily. Yeah, that's actually the score. So the first column, the variable view, click it on variable view, and just call that memory score, mem score. We could have named these first, Alexis, but we
Okay.
actually did it second. And the second one, you might just call condition. You can actually go and name these things first if you want, and go back to the data view. And now we have 1, 1, 1, and 2, 2, 2. Beverly, were you able to set it up correctly?
Yes, I got it.
Okay, so now we put the information in. The other thing we learned last week, and I'm sorry about the slightly backwards way of this, we learned how to do value labels. Emily, do you remember anything about value labels?
Probably.
Probably, but probably not. I don't know if I covered it in the acoustics, but let's go into this. Go back into the variable view. And go into values for condition. Go where it says into values for condition. Down one. And click it on the right-hand margin there. The right-hand margin under values where it says none right now. Nope. The right-hand margin in. Yep. Nope. A little more. Click it on that. Beverly, are you into that?
Yes, sir.
And for value of, put the value 1. And then the label. Was that the 5, 6, 7 we had?
No, 1, 2, 3.
1, 2, 3 were the first 3 numbers. So value 1, put the label no drug.
Is the this one? You still do one word?
Yep, it could be two, I think,
Okay.
actually, sometimes. And add it. Added them. Add it. There you go. And two. And it would be what?
With
Drug. And add it. And then click OK. And now, go back to the data view. Notice it still has the 1, 2, 3, but the other thing we can do, Beverly, are you with us?
Mhm.
The other thing we can do is now, if we want to actually see the labels, go into View on the top. View. View, Emma?
Oh, sorry.
That's okay. View.
You...
To the left, to the left. And click it on Value Labels. This is the way that SPSS gets around the problem of it hates words. It hates string variables. So the way you do a string variable is you create numbers and then you put a value label on it. It fixes that.
Okay.
Beverly, is that good for you?
Mhm.
Okay, so let's keep going and let's actually do our analysis here. So could we actually do an ANOVA? We could. So let's go into Analyze. Emily, do you remember how to go into an ANOVA?
Analyze, compare mean.
Compare means,
One
and then
way.
one-way ANOVA. And then it says, what's the dependent variable?
The memories.
Memory score. And instead of calling it an independent variable in ANOVAs, it's actually called a factor. A factor is the name of the independent variable, so put factor in there. And then click it on OK. Put for you it's a condition. Sorry about that.
Oh.
Condition. Nope. Back.
Oh, put that. Oh.
Go back with that and put that
Put it
in
down
factor. There you go.
here.
You got it.
Okay.
You got it.
And then
And
hit
click it
OK.
on OK. And now it's going to do it. And if you look at your printout, does it look very similar to your printout?
Yes.
Yes,
Yep.
because Dr. Tausman knows how to do it. So let's go over this, and you should know where to get all these terms from, because we tried to do this out by hand. Sums of squares between groups. Do we want that number, Alexis, to be large or small?
Large.
Yeah, we want that to be large because that reflects treatment. That is measuring the treatment effect. And we want that number to be large. We get 24 because we did those computations with get the mean of the first group, which was what was it?
2.
2 minus 4, quantity squared, times 3. 6 minus 4, quantity squared, times 3. And that's 24. So we want that number to be large. And then 1 degree of freedom. Where does that come from? Emily, do you remember where 1 degree of freedom comes from?
That comes from
Mm-hmm.
the, I don't remember.
Okay.
All right, well, I'll tell you, every time we've done degrees of freedom, I think I know what we're doing, and then I really don't.
Okay.
Because I always thought it was, there's 3 in one group, 3 in the other, and you minus 1, so then it's 2 and 2, but then I thought you add them.
That's kind of right,
Okay.
but for something else.
Oh.
Emily, do you want to clarify a little bit?
For this case, within the between groups, it's both groups minus 1.
Yes, there are 2 different issues here. One of them for degrees of freedom between groups. The way you have to phrase it is you have to say, how many groups do we have? If you have 2 groups, then you have 1 degree of freedom between groups.
Okay.
So that's between groups, degrees of freedom. So it's always how many groups do you have minus 1.
Okay.
And
That's
so the
between
mean
groups.
square is simply another term for mean square. Beverly, do you remember what the other term is for mean square?
I don't remember that.
It's actually variance. So when it says mean square also stands for variance between groups. So sums of squares between groups, 24. Degrees of freedom between group, 1. So the variance between group for the F ratio is 24. So let's go now to the sums of squares within group. And once again, we want that numerator to be large. Go ahead.
That's where I have degrees of freedom.
Yes. to get the degrees of freedom within group, you're exactly correct. That you say, how many people are in the first group? 3, 2 degrees. How many people in the second group? 3, 2 degrees of freedom, add them, and you get 4 for the degrees of freedom within group.
Okay.
How about the 4 for the sums of squares? Beverly, do you remember how you get the 4 for the sums of squares within group?
Yeah, I'm gonna have to look back at my notes from last week. It was that formula.
It's a formula, but you just have to think about the data sets. You have the numbers 1, 2, and 3, and 5, 6, and 7. Emily, do you remember what we know about 1, 2, and 3 and the sums of squares of any 3 consecutive numbers?
Oh, it's 2.
Yeah, the sums of squares of any 3 consecutive numbers is 2. So 1, 2, and 3, 1 minus 2 squared, 2 minus 2 squared, 3 minus 2 squared, or you can just know 2. And then 5, 6, and 7, sums of squares are 2, so you add those up. Sums of squares within group is 4. And so to get the variance within group, it's the sums of squares within group 4 over degrees of freedom within group 4. So the variance within group is 1. Do we want that number to be large or small, Emily? Do we want the variance within group to be large or small?
We want it to be small.
Yeah, because that reflects error. People getting the same treatment, we don't want them to be very disparate from one another. So that reflects the variance within group. We want that to be small. What happens if I get a F value or sums of squares that's negative? What does that mean? If you get a negative value, Alexis, what would you think that would mean? Let me ask Emily the question. What does it mean if you get a sums of squares or an F score that's negative, Emily?
That's bad.
It's really bad. It means you did what?
It means that you didn't know, there was no treatment effect
Nope.
whatsoever.
It's even worse than that. Beverly, do you know?
It means that
Means you
that-
screwed up.
you messed up and the treatment effect went the other way.
No, it doesn't even mean that. If you get a negative number, everything here is squared. You can never get a negative number for an F score. Never. Because we're squaring everything. So if you get a negative value, Beverly, did you know that one?
I didn't know that one, but it kind of makes sense because you said in one of the lecture videos from last week that the the T value is
T squared, yeah,
S value squared.
T squared equals F. So exactly the case. Don't worry, we're good with that, Emily. So the idea here is we get an F score of 24, and then the computer actually tells us that the probability of getting that due to chance is 0.007. Is that significant?
No.
007. You're saying no, Alexis? Do you remember what the key probability is? What's the key determining value for significance?
0.05.
0.05. And what's the idea? If the p-value is less than that,
Right.
you are significant.
Right.
So the idea is this result, you can get an F score of 24 less than 1% of the time due to chance. And because it's less than 1% of the time,
It's
it
0.007.
It is significant. Yeah, 0.07 is the problem one. That's right. Yeah, don't worry. Emily was getting confused on all the 4s we were getting and where the 4s were coming from, because there are a lot of 4s, but you got to know where it's coming from to figure it out. So
Okay.
0.007 is significant. So you would write it out of F of what? 1 and 4 equals 24. And then you'd write P equals 0.007. And it is significant. The drug improved memory. Now, the other question Alexis was asking that I want to go over here as we finish this one off is how would you actually look up if you computed this by hand to see if it is significant? And so we'd have to go to the very back of the book. I don't remember the page now, but we can find it.
Oh, it's 704.
704. Woo! Close. It's, 705. If you turn your book to 705. Beverly, were you able to find in the book the F distribution?
I was, yes.
So if you turn to page 705, Emily, help me out on how you would figure out if it's significant using the table.
the degrees of freedom between groups
Is what?
is 1.
1. So you go on the column going 1 there. And then what are the degrees of freedom within group?
4.
4. So we have 2 critical scores there. We have the 7.71 and then the 21. Our score is 24, so it's above that. So you could simply, 0.05 is the main one. So the 7.71, if you didn't get the printout of this, you could look it up in the book and say, hey, it's significant at the 0.05 level. It's even significant at the 0.01 because the probability exactly is 0.008. So you just look it up. You will be asked to do this for the test. You will be asked to do a 1-factor ANOVA, and then you'll have to get the degrees of freedom numerator and denominator. It's probably going to be the 7.71 because I always do 3 and 3 in 2 groups, and then you can look it up and see, okay, this is significant. Does that work, Alexis?
If your F is higher than the number that you're seeing.
Then it is
in the book.
significant. This will be really the
Okay.
last time we do this because with SPSS, we don't need to be looking up
Right.
book things.
Okay.
Beverly, does that work for you?
Yes, sir.
Okay. The last
wait,
thing.
what did you say if the number is higher than...
If your F score is higher than the number in the book, then
Yours.
it is statistically
Then it is
significant.
God.
Yep. And the last thing we'll cover actually on this one, let's go to that T example. Go back into Analyze just for a minute or two. Go back into Analyze.
Close out of this.
Nope, you can stay on that screen.
Oh.
Go into Analyze.
Okay.
Emily, just go into Analyze. And what was the other statistic we could do on this? You don't have to exit off, Em. Just go into Analyze. You could do an independent sample t-test. So if you click it on that, now you have to name what's the test variable. That's the DV, the memory score, and condition. Nice dog there. We heard that.
Yeah, she misses her mother, and she
Define the
is
groups.
high.
And it's 1 and 2. So define the groups there, and 1 and 2. And just continue. And click OK. And then, what's our score there? What's our T score? T obtained. 4.8.
4.899.
And if you square that, did you get that?
Oh,
Yep.
okay, yeah.
T squared equals F.
Okay.
So, that's the lesson for there. The final thing that I think I'd like to just share here is, since we did it, the Levine's test. Alexis, did you understand that from last week?
Yes.
So you look at the significance here, and which line would you be using for our statistics here? Would you use the top line or the bottom line?
You know, I never understood the T squared. I mean, equals F.
T squared, because an F score is 4.899 F. ANOVA square everything. Everything is squared.
Yeah,
T's,
but
don't worry about it. Just
that's
T.
16.
So let me ask Beverly.
That would be around 16.
No,
or-
4.899 is 24. It's almost 5. Beverly, do you remember the Levine's test situation, or should I clarify that?
The Levine's testing is if you have a sig value of 1, would you go? You read the top line.
That's
and if
right.
it's- Yeah.
The whole idea there is Levine's test is not testing for significance of the treatment or anything. It's just saying the two samples, are they coming from populations that have equal dispersion, equal variance? And if you remember last week, it was the 123 billion, that they have very different dispersion. So the Levine's test would say less than 0.5, and then you have to use the bottom line saying equal variance is not assumed. So if your Levine's test is greater than 0.5, where it says sig 1, because you have 1, 2, 3, 5, 6, 7, the populations are really the same dispersion, then you use the top line. If the Levine's test for significance is less than 0.5, you simply use the bottom line. Okay, we're good for that part of the review. Any questions? I've been babbling on for 20 minutes here. I hope this works.